So, next up, we have a speaker who really needs no introduction. For over 4 decades, he's been one of the most courageous voices in climate science. And he's the scientist that first brought global warming into the world's attention when he testified before the US Congress in 1988. He is the former director of NASA's Goddard Institute for Space Studies and the current director of the Climate Science Awareness and Solutions Program at Columbia University. His groundbreaking research has really shaped our very understanding of the Earth's climate system. We had the amazing privilege to collaborate with him on his latest report on the acceleration of global warming. And that's work that directly speaks to why we're all here today. So it's my great honor to welcome to the stage Dr. James Hansen.
Thanks very much. Good morning. Climate change is characterized by delayed response and amplifying feedbacks, which are a recipe for intergenerational injustice. So we have an obligation to clarify this and to not shirk from describing the implications. Climate sensitivity is the most basic issue. The Charney sensitivity refers to the case in which ice sheets on Greenland and Antarctica are fixed. Charney's estimate had a huge uncertainty from 1.5 to 4.5 degrees. Today, the best estimate of IPCC is still 3 degrees. If there were no climate feedbacks, sensitivity, ECS, would be 1.2 degrees, which is the warming needed to radiate 4 watts per meter squared of energy to space, which is the amount of radiation that doubled CO2 blocks from the Earth's surface. Water vapor and sea ice feedbacks are approximately double ECS to 2.4 degrees. Cloud feedback is the big uncertainty. Charney based his estimate on 2 GCMs, global climate models, that differed in their treatment of moist convection, cumulus convection, as I will discuss later. I will conclude with more than 99% certainty that climate sensitivity is higher than 3 degrees, based on 4 independent evaluations. Paleoclimate should provide our best measure of climate sensitivity. We can compare 2 equilibrium climate states, and if we know the forcing that maintains the climate change, we have a direct measure of climate sensitivity. Ice core data reveal atmospheric composition during the last glacial maximum, the LGM, 20,000 years ago. But we also need the global ice age temperature to infer sensitivity. The large CLIMAP and MARGO projects estimated that the LGM was only 3 to 4 degrees colder than the Holocene, the present interglacial period, based on the distribution of microscopic species in the ocean, which is a dubious measure of temperature. Just recently, Jessica Tierney used chemical proxies, finding that the LGM was actually 6 to 7 degrees colder than the Holocene. And Alan Seltzer used noble gas abundance in groundwater deposited during the last ice age and found temperature consistent with 6 to 7 degree global cooling. The upshot of 6 to 7 degree cooling, LGM cooling, is climate sensitivity near the upper end of Charney's range. This paleoclimate data by itself excludes the IPCC 3-degree sensitivity with more than 99% confidence. Source number 2 is the rapid, strong darkening of Earth in the past 25 years. Satellite data show that Earth's albedo, its reflectivity, decreased 0.5% in the last 25 years. So sunlight absorbed by Earth increased 2 watts per square meter. That's a big deal. But don't double count it. This is not a 2-watt climate forcing. Most of it is climate feedback. Part of the albedo change is due to decreased aerosols, small particles in the atmosphere, particulate air pollution, which is a forcing that might be as large as about 0.5 watt. But most of it has to be cloud feedback. Such a large cloud feedback implies high climate sensitivity, surely larger than 3 degrees, but it's hard to say exactly from this non-equilibrium change until the data record is longer. Source number 3, global temperature change in the past century, is the most ambiguous source, but it is the one IPCC focuses on. Global temperature is an ambiguous measure of sensitivity because there are 2 large climate forcings, greenhouse gases and aerosols, and aerosol forcing is unmeasured. The crucial period begins in 1970, when temperature began to rise rapidly. IPCC takes aerosol forcing as nearly constant from 1970 into the early 21st century, in which case aerosols have little role in global temperature. Global sulfate emissions are the basis for IPCC's estimated aerosol forcing. But aerosol forcing occurs mainly via the effects on cloud formation that are nonlinear. Aerosols added to a pristine air have greater effect. During 1970 to 2005, aerosols spread more globally into Southeast Asia and over the ocean as ship traffic increased, surely causing aerosol cooling. IPCC's aerosol forcing requires climate sensitivity near 3 degrees to match 1970 to 2005 warming. But if aerosol cooling increased 0.5 watt, the best fit becomes 4.5 degree sensitivity. We can discriminate among these 3 cases by asking which one fits the entire period, 1850 to 2004, best. And the answer is 4.5 degree sensitivity. But this observed warming is the weak indicator of sensitivity. Information source number 4, planetary evolution, is interesting. To appreciate it, let's go back to Charney's 1979 study. Charney focused attention on moist convection, cumulus convection, which lifts moisture and heat from low levels to the upper troposphere, reducing low clouds and increasing upper-level water vapor and cirrus clouds. In Charney's study, models using layer average adiabatic adjustment to move water vapor and heat vertically yielded a sensitivity near 2 degrees. But models that parameterized moist convection, allowing moisture and heat to penetrate to higher levels, yielded 4 degrees. Well, Charney took the average of these as his best estimate. But we now can indirectly can test the effect of cumulus convection, thanks to a version of the Goddard Institute model developed by Gary Russell that can be used for a wide range of climates. Runaway snowball Earth occurs in the model when CO2 declines to 1/8 of the 1950 CO2 amount, a forcing of -12 watts per meter squared. That's equivalent to a 6% decrease of solar irradiance. Solar irradiance is changing 1% per 100 million years. So 600 million years ago, solar forcing was -12 watts per meter squared. And indeed, the last snowball Earth, when land ice reached sea level at the equator, occurred 600 million years ago, which provides a nice check that supports the high climate sensitivity. The conclusion is that climate sensitivity is substantially higher than IPCC's best estimate, and negative aerosol forcing exceeds their estimate. So between those two, we've got a big problem. It's solvable, but we must understand the situation and the options quantitatively. Accelerated warming since 2010 is real. It's forced. It's not feedbacks running amok. Global temperature has now reached 1.5 degrees, averaged over the Niño cycle, and it's headed higher. How do we know that? Spatial and temporal distributions of absorbed solar radiation measured by satellite helps us understand this, even though it's hard to apportion between the aerosol forcing and the cloud feedback. Increased absorption is mainly in the northern hemisphere, especially over the North Pacific and North Atlantic. Its timing in the last 10 years suggests that the ship aerosols have more effect than the reduced China aerosols, because the regulations on ships were changed in 2015 and 2020, which reduced the aerosols from ships. But it's a secondary issue as to the apportionment between China and the ships. Aerosol forcing increases heat radiation to space immediately, while cloud feedback grows only slowly as the global temperature rises. So heat radiation to space, again, the temporal change of that suggests that aerosol forcing was added mainly since 2015. The large increase of heat radiation in the past 2 years is a response to the large jump of global temperature in those 2 years, which reduces Earth's energy imbalance. But the imbalance is still more than 1 watt per square meter, which is double that during the first decade of this century. The implications are great. The 1.5 degree warming level has been breached, and global temperature will rise much higher because the planet is still out of energy balance. We don't need to wait 10 years to conclude that. Someone should inform the United Nations Secretary General, who keeps saying that we can still keep warming below 1.5 degrees. In fact, global warming certainly will exceed 2 degrees. Greenhouse forcing is increasing at the astounding rate of almost half a watt per decade. The RCP 2.6 scenario, which was designed to keep warming under 2 degrees, is now impossible. We are closer to RCP 8.5. We cannot keep warming below 2 degrees without purposeful actions to alter the planet's energy balance. The problem is still solvable, I believe, but young people need to be honestly informed about the situation and how old people screwed up. We must get the carbon intensity down of our energy down to near zero by mid-century. But in 50 years, the world only reduced from 0.8 to 0.7. Sweden and France showed how to get halfway there in the 1970s when they decided to build nuclear power plants. Going the rest of the way would have required a rising carbon fee and development of next-generation nuclear power. Instead, the opportunity to address climate change was abandoned. 33 years ago, Al Gore and Bill Clinton were elected, and in the first State of the Union address, Clinton announced, "We are terminating R&D on nuclear power, which is not needed." In so doing, they tied one arm of young people behind their back. Now, other old geezers want to tie the other arm of young people behind their back and pass laws that say you are not allowed to take action to purposely alter Earth's energy balance. For example, with solar radiation management. So then the old geezers go off to die, and young people are left with 2-degree global warming locked in, out of their control, and both arms tied behind their back. So why is this important? 10 years ago, we wrote a paper saying that 2-degree warming is highly dangerous because it will lead to shutdown of the overturning circulations in both the North Atlantic and Southern Ocean by mid-century, and probably multi-meter sea level rise within 50 to 150 years. Reaching these conclusions requires using information from Paleoclimate, from modern observations, and from climate modeling, all in the same paper, all in the same head. It's hard, but we can only get to answers soon if we use all sources of information. An IPCC lead author tried to block publication of this paper, which is the same problem I had in 1988, where they do not want to look at all of the information from the different sources. They look at a given temperature curve linearly and say, well, we can't yet say for sure. Well, we've got a lot more information. Nevertheless, although this paper then was reviewed by 4 referees, and all of them except the IPCC lead author agreed it should be published. But then the editorial board got involved and changed the title from "is highly dangerous" to "could be dangerous." That is scientific reticence on steroids. A crucial point in our paper was the first description of the feedback that occurs with melting of ice shelves. Increasing ice melt and increasing precipitation reduce the density of surface water in the polar oceans, thus blocking the escape of heat from the deep ocean, which then accelerates the melting of the ice shelves at depth. There is evidence of this feedback in paleoclimate, in modern data, and in our global climate model. Models need to correctly simulate deep water formation along the coast of Antarctica, which our model did. So, are we doomed to have large sea level rise and lose a majority of the world's large cities, which are mostly coastal? We did GCM experiments anticipating that this Antarctic bottom water formation feedback would work the other way if we cooled the Southern Ocean surface with solar radiation management, assuming stratospheric injection of Pinatubo-like aerosols in 4 different areas, as shown by the shading here. These were done for a meeting in Xi'an, China in 2018. As expected, the stratospheric aerosols produced global cooling at the Earth's surface. The important result is that the Antarctic bottom water formation speeds up if you cool the surface, which opens up the escape valve of heat from the Southern Ocean, which cools the ocean at just the depths that are most effective for stabilizing and even regrowing the ice shelves. My point is that that large sea level rise is not necessarily inevitable. We may be able to take actions to avert it, but we need comprehensive research to address this issue. One other merit of stratospheric aerosols is shown by the airborne fraction of fossil fuel CO2 emissions. In the 2 years after the Pinatubo eruption, 1991, 1992, 75% of fossil fuel emissions were taken up by the ocean, the soil, and the biosphere, the most of any year in the entire record. It seems that a little cooling is good for the planet. People might also benefit from a little cooling. The experiment has been done in nature by the volcanic eruption. The danger in taking actions likely to be smaller than the dangers of not taking action. Finally, I would like to advocate that we scientists work with our Chinese and Indian counterparts. Such cooperations may help our governments understand that those countries are not our enemies. China is doing a spectacular job of moving toward clean energies. If we would work with them, we could drive the carbon intensity of energy down rapidly. We're not doing that. We could do that, but it requires some fundamental actions. We have allowed climate to reach a precarious state, and the world will soon understand that it is now a hard problem. Nevertheless, I argue that the solution is now as simple as 1, 2, 3. But these things are not happening, even though they're sensible. And if I make one more comment, the bottom line of the book that I'm writing now, Sophie's Planet, is that the way to solve the problem is to get the role of money out of the United States government. The public in the United States knows that Washington is a swamp of special interests. The reason we needed to create an enemy in China, and if you start talking about them as an enemy, eventually they become an enemy. It's like the parable in the Bible about the man who asked, he's coming to a new city, and he asked a man there, what are the people like in this city? And he said, well, what were they like in the last city? And he said, they were all crooks and bums. And he said, well, they're the same in this city. Then when the next guy came and asked, and he said, well, the people in the city I came from were all honest, hardworking people, and they would give you the shirt off your back if you needed it. And he said, well, they're the same in this city. So if we treat China like an enemy, then they become an enemy. But we need to work together, or we're not going to solve this problem. But presently, in the United States, both political parties take money from the military-industrial complex, from the fossil fuel industry, from the pharmaceutical industry, from the gun industry. And so the public has a lot of things they would like to see get done, but they don't happen. There's a reason. Our democracy is no longer functioning as a democracy. You have to get the role of money out of government. And the amazing thing is that young people have the power to make that happen. I was on a university campus in 2008 when Hillary Clinton was expected to be the Democratic candidate for president. She was the preferred candidate of that political party. But young people were started to like Barack Obama, and they managed to get him to get the nomination. It was only because all these young people got involved. So, and there's another case that happened again where Bernie Sanders, who could never get elected, but young people at all the campuses on the country almost got him to get a nomination. So the young people have tremendous potential to affect the political system, but they have to know what needs to get done. And I think we have, in the United States, we have to have a party that takes no money by definition. And the thing about young people is they communicate with social media. They don't need billions of dollars for a campaign. They can do it completely free of charge. So if that doesn't happen, we're in trouble with the climate problem because it's not going to be solved as long as the special interests are controlling our governments. And okay, I'm done. But I went to, a dozen countries, and they're not as bad as the special interest situation in the U.S., but there's still the fossil fuel industry has a big impact, which has to be addressed. Thanks.
Thank you so much, Jim.